I'm super excited about today's video because we're going to architect an NVIDIA Omniverse CAD-to-USD pipeline that preserves structural intent by giving downstream design teams real-time feedback if they make invalid changes. If you're familiar with OpenUSD, it has built-in constraints through LIVERPS that enforce outcomes through what's called layer strength ordering. While that maintains structural integrity in the end, that's not always helpful for user awareness. Now let's say a designer gets ambitious and tries to move a load-bearing column because it blocks their view out of a beautiful window in a lobby. Well, their changes would either be ignored or rejected downstream. And when you're architecting pipelines, rejections are something we should try to reduce in the production workflows since they can be costly. So before we get started, let's do a quick project overview. As an architect, we wear different hats. We're going to think like structural engineers who are the data authors. We're going to think like the designers who are the consumers of this data pipeline. We're also going to think like the pipeline dev teams who are the maintainers of the pipeline. So we're going to design everything with them in mind and try and optimize the system so that it's as streamlined as possible and as easy and intuitive to use as we can make it. We're going to use Omniverse Kit USD Composer, which is a reference application that Omniverse has to kind of give you an idea of what kind of things you can build. We're going to convert a CAD JT file to USD, and then we're going to optimize that, and then we're going to semantically enrich that by tagging the prims. And this has many different use cases. It doesn't necessarily have to fit this particular one we're doing today. We'll get into how LIVERPS enforces outcomes, but really doesn't inform users if they make a mistake. We're going to create an extension to enforce the boundaries at runtime and help reduce those mistakes and reduce rejections, which in turn saves time and money, which is exactly what your bosses want. We're going to use variants to show how a design team might show different proposals and to demonstrate how LIVERPS works within design workflows. We're also going to get into why I love USD. We're going to show its simplicity under the hood and kind of explain how it's both a file and a data structure that has extreme amounts of power, but those rules are the things that make it so powerful. So let's go ahead and hop into the project and get started. Now we're going to start off by taking this CAD file from Onshape, which I found on their public library of assets that you can check out. I don't know Onshape very well, but it was a perfect example for what we're going to do, where we're going to show that a designer is going to add styling to these columns. And there's differences in the columns. They're not all exactly the same. So to get this out of the CAD file, we're going to go ahead and select everything in here. I need to make sure I get everything. I don't want to export the entire project because there's multiple tabs, and all I really want is this lobby, is what we're going to call it today. So we'll just simply select everything, right click and hit export, and we're going to go to the JT format, which is a universal or open source data format for CAD, and we're going to download that. The next thing we're going to do is open up that JT file and convert it in Omniverse, but what we need to do first, if you haven't already, you're going to want to get the Kit app template downloaded, and you're going to want to have that up and running. There's some prerequisites that I'll put some links in the description, and they're also in my blog article that I'll put a link in there too for, so that you have all the resources to get up to speed with this. But basically download this and get Omniverse up and running. And here you can see I've got it open in VS Code, and I've already built this. Normally, if you're running PowerShell, you do a repo.bat build, and if you're in Linux, use a repo shell file to build it. I've already built it here, so we're just going to go ahead and launch it. And I've got this in memory here, so we will just kick this off. This is going to run the My USD Composer Kit app. And once that's done, you're in USD Composer, and we're ready to get started with that conversion process. All right, we'll navigate to the file that we just downloaded, and then you can see there's our lobby JT file. And in order to convert it, we're going to right click and hit convert to USD. Now this is why we're using USD Composer, because it already has that built in here, so that normally you'd need to set up the extension. And once you right click that, we're just going to go ahead and keep the defaults here. And notice that you know, there's some things you can change which are not really, they're kind of out of scope for this video, but we'll go ahead and hit convert. And that conversion process is complete. So now what we have here is our lobby structure, the engineering CAD file that gives us the beams that we're going to work with. Okay, so you'll see that the lobby USD file has been converted and created, but what we're in here, we haven't saved anything, so we're still in a new stage. We want to go ahead and open this up. So we're going to open that file. We don't need to save what we've got here. And that is going to give us our asset here that we can work with. You can see the beams that we're going to work with here. But what we want to do next is optimize this file, because there's going to be a lot of meshes and things. There's a lot of details that come over from the CAD file that really aren't needed for this part of the project. So we're going to streamline this and make everything run better. To do that, we're going to go up to the Window, Utilities, Scene Optimizer, and there's a variety of different presets that you can set. And really all we're going to do today is merge meshes, and so I'm going to go ahead and execute all of those, and then we can see the report. Now this was a pretty clean file. This is just an example, so we didn't really have a lot to merge, but that's pretty much it. Now what we can do is save this lobby USD file, and if we refresh the browser here, I'm going to back up a little bit. Sometimes the browser doesn't completely refresh. Okay, once that's done, you can see we've got our lobby JT, which is our original CAD export, and then we have our lobby USD, which is now optimized and now converted and optimized and ready for us to work with. Once you're done with the conversion and optimization process, it's probably really important for the engineer themselves, or at least someone who's familiar with the structure, to go through and verify that the assets, or all the prims, are in place and nothing has broken. You can go down the list here in Omniverse on the stage and actually see all of the prims, and then you can compare that to the prims that are in your original CAD application, in this case Onshape. So you can see each one of them here. And so that's just probably a good practice to get into, make sure that someone validates that the conversion went well. Now that we have our CAD file exported and converted to USD and optimized, we're ready to start tagging our structural prims so that we can access them using an extension. If you're in a large project file, you can write a script to optimize this process, but since there's only 6 columns in this entire building that we're going to focus on, we're just going to go and search for them here and do it manually. Sometimes by the time you write a script, you might as well have just done it yourself, but this is one of those cases where we'll just make it easy here for the demonstration purposes. And now we're just going to use each column, and each column has a top and a bottom. So whenever you look at, there's a column T for column 5T, and there's a B for the bottom. We're going to go and tag all of those just so that we have that in place. And we do that by simply hitting Add, Attribute, and I've already pasted it in here, Structural Protected. That is basically my namespace, and the purpose of this tag, we're going to set the data type to Boolean, and we'll add it. Already exists. Yeah, cancel. Once we have the asset tagged, you can search for Structural Protected, and we can set that value to true so that we're making sure that it's done. And we'll also do that to the bottom here and hit add. Oh, we've already added that to this particular one, and we'll go ahead and do that again. I found that you kind of have to click off here. There we go, attributes, got it loaded, and we can just, you can see how this becomes pretty straightforward as we walk through the process. Just a matter of clicking the right spot. I imagine a script that would look for every column and do this would be a whole heck of a lot easier, especially if you're in a large building. Now notice that we're going to have some columns that are tucked over here. Attribute, add that. And I'll go ahead and just walk through the rest of these, speed this up for you so that you don't have to sit here and suffer while I do this. Again, there's only 5. The tagging that we're doing here can be done for a variety of reasons. It could apply to a lot of different use cases. In this case, we're just doing it for structural components because that's the particular use case example that I have. But it's really going to help you access these prims through code. So if you ever need to do anything else with them, you can imagine there's a lot of potential here. What we're going to do now is we're going to create the layer for the designers to come in and add their opinions to how these columns might look. So we'll go ahead and go up here and use this new from stage template, create an empty one. We'll go ahead and set the, I don't know, I like the default light. I think you can set a different gray studio or whatnot. And in this case, we're going to create a new layer first. So we'll create a sub layer and we will call it lobby structure. Best practice, I think, is to capitalize this. We'll save that here and say we do not want to bring in all the root layer contents. And we're going to make that the authoring layer. That's a key detail here so that we can retain our original structure. And then we're going to create a scope. And a scope is nothing more than a folder that holds the files that we're working with. So we can rename that as lobby. I can't type today. And there we are. And now you'll see that is underneath the lobby structure USD and in our stage and under the layer. In the stage, we're going to right click this and add a reference, which will bring in the lobby USD structure file itself. This is more or less, again, just a read. This will become a read-only layer that we can reference as our original source, and it you'll notice that this comes in kind of wonky. All you got to do is click on the root layer, navigate to your world access, and change that to Z, and then you'll be able to see that is set up correctly. Now that we have that in position, we can take this authoring layer here. You can't lock it when it's in the authoring layer mode, so we need to move back up to the root and set that. And now if we click this lock here, it's in read-only mode, so anything we do to this layer is not going to get recorded. And that's kind of where we'll get into the extension stuff later. But first, let's go ahead and create some additional layers here for the designers. We'll do that by right-clicking the root, create, whoa, mouse is going all over the place, create sub-layer, and we'll call this, column base. Because what we're going to do now is we're going to save these columns. We're going to alter the columns, but we want to have the original. Sure, the original is stored in this layer here, which is now read-only, but we're going to add the variant drop-downs, which will actually apply here. We're going to set up all of that structure at the base level so that you can see what the original design looked like. To do that, we're going to navigate to a different, let's change our position here just a little bit. So we can, let's hide the wall top. There we go, now I can see all of the columns at once. Zoom in a little bit. There we go. You can see this column here is a completely different shape, so you can understand why these aren't instanced. If you're familiar with OpenUSD, instancing is best, especially on massive files. So if I can zoom in a little more, there we go. That seems like a good position. And so it kind of is important to understand that that's CAD does what CAD does. The engineers do their work, and it may not come through as optimized on that side. So, you know, It's really good practice to save your files, which I did not do. This is our overall project where we're doing the design work. Shame on you, Rob. Let's go lobby design. And we're going to make it a USDA, so it's the human readable version, so we can come back in and see that later. We'll check that out when we're done. And I've got some other ones that I haven't saved too, so that's always save your work, man. It's just important, right? Now, if I hide this base, you'll notice I made a mistake. I forgot to adjust my authoring layer, and I'm authoring on the root, so when I ended up hiding the wall, it hid the wall in the entire project, and I don't want that. So I need to come down here, open up the world, the lobby, and you can see there's wall top right there and column 4. I don't want any changes there. To make sure I remove these changes from the project, I just click these and delete them and delete the delta. And now you see my wall comes back. Now, if I click the base USD layer, which is where I wanted my change here, so we'll set this to the authoring layer, and then I can come up to wall top and hide it. Now, when I hide, I can't hide my authoring layer. This is where USD's fun, I guess. It's not my favorite, but now I can hide it. It's just a matter of tracking every little detail, making sure that you're following those rules so that things work the way you expect. And if you don't, you kind of backtrack a little bit. So try to check your work as you go. So now we have the column base, and we can hide it and show the original structure, show it and show the designer preferred view. We're going to go back to setting this to the root. Setting it as the authoring layer. And we can go ahead and add the variants to the columns. So before we do that, just to give you a quick summary of what we've done, just kind of check in. We have our stage with our lobby, which is a reference file, which references the original USD file, which is the source of all truth for the engineering structural components. That is built into the LIVERPS and the strength ordering, as they say. Because it's a reference file, when someone imports this lobby USD, it is the source of truth. We've imported that here, and we've locked it down so that we can't make any changes to it. So if I did hide the wall, it wouldn't show up. And then, but that doesn't mean you can't move the columns as a designer, and we'll talk about that a little bit when we get into the extension to help them understand, hey, bro, you're making a move you ain't supposed to, so let's not do that. But first, let's set up that designer perspective so we can change the column design quickly. Because these aren't instanced, you can't just literally drop a material on one column and have it show up on all of them. That is the wonder of USD. If I had one column repeated 6 times and I drag a material onto that column, it would show up. In this case, it doesn't. So let's go to the base materials and just show you how that works. Boom. Only one. It'd be cool if they all did it at the same time, but that's just how this particular project goes. So I'm going to go ahead and delete that column 5 change here, delete that delta. And so now all we have is the wall top hidden. You can see how this layer is recording those changes. This is the LIVERPS in action. So to set up variants, one of the things we need to do is, let's pull this out a little bit, get my mouse right on that line and pull this over. We'll right click, or not, you don't even have to right click, it's a hamburger button. You click it, go down to columns and say variant. We won't worry about payloads today, that's another conversation. Now we can see that there's an option for variants here. Let's go ahead and set some of those up. We'll start with this column here. Actually, let's do a search. Make this easy to find them all. We know we're looking for the tops because we're not going to worry about the style of the bottom ones yet here. We will filter for all the column T instances. And what we can do now is click on this, right click on this, and add a variant set. If you can get your mouse to line up with the menu, click that. Now we can rename this to style. Then we'll add a variant. When you click on that variant, let's just rename this one to base, because what we want to do is retain the existing column design. And we're going to add a prim. We're going to click the poly shape and select it. Then we're going to add a property, and we're going to, any of these properties are things that you can change here, so you can create variants on lots of different things, but we're going to bind the material to that. And you can see we're using material 11, which is the material that came in when the file was converted. Now that we have that property set up for this variant, we can duplicate the variant, change the name to, in this case, stone, select it, and we'll drag stone into the material here, and let's double check that we've got this set right. Well, let's do one more. Let's do the wood next. Let's do duplicate the variant again. And in this case, I'm going to come down to ash planks and drag that in here. And I forgot to rename it to wood. Let's go ahead and close this and check that everything's working. There it is. Okay, so now we see column 5 has wood selected, stone is selected, and base. Because this is our base layer, I want base to be selected. So I'm going to go ahead and keep that. And this is another one of those areas where, like I said, instances are nice, because if you can use instances, you drag the material onto one column and all of them get it. But since that's not the case in this particular project, we get to rinse and repeat, do the same thing over and over again. So I'm just going to go pick column 6, just happens to be that one, right click, and we'll do it again. So we'll get some muscle memory in here. Variant set. Rename the variant set to style. Add a variant. Rename that variant to base. Click that variant. Add a prim. You see the only one that's available because that is the one we have selected up here. Add the property. Click material bind. And now we've got the base, and duplicate that. Right click, rename stone. Don't worry, I won't bore you with all of these. Drag the stone material out. Right click, duplicate variant, rename variant wood. And we use the ash plank, which is right here. Now, I'm just picking random materials and things. This is just an example use case. But so just to save the time, I'm going to go ahead and fast forward through this whole thing, but I'll let you watch. So let's go ahead and close this. Make sure that we get the wood set to base. Just verify that stone's working. Looks good. All right, so let's get moving on getting the rest of these done. Okay, I made a mistake, and one thing you got to be careful of is I just applied the wood texture and wood material to the stone variant. And that's, you got to be real careful not to do that. So it's always good to double check your work. And that column's all the way back here in the corner. We got it set to stone, set to wood, change the base. Moving on. Okay, now that we have all of that done, the point of all this is so that we can set these and basically group them under a layer, and then that way you can hide or show, toggle the different views really quickly rather than having to go through the whole process and adjusting each column one at a time. So let's show you how that looks here in a second. Now that we've got the base set up, it's got all of our variants with the wood and everything. Let's watch how easy it is to create these other variations now. We'll come back to the root layer. We'll create a new sublayer. We'll go ahead and call this column stone. Column stone. We will make sure this time to set it as the authoring layer. And now that we have this selected, all we do is change each one of these to stone. Save the project. And now if I set the authoring layer to the root, I can hide the stone and show the base rather than have to go through and change each one individually. So I can show the base, I can hide the design layer. Now you can see how the structure of the layers is critical to streamlining the workflow. Whoops, I set that as the authoring layer. I want to create a new sublayer, and we're going to call this one column wood. Save that. Set that as the authoring layer, critical piece. And we can hit wood on each of these. And once we've done it, it'll be super easy to toggle that view. As long as we set this to the authoring layer, we can hide the wood, show the stone, hide the stone, show the base, hide the design layer altogether. And you can see we've now maintained the structural integrity through the, and then kept the base style where we added all the variants in this layer here. You can see that our lobby has the wall top hidden, each of the columns is set up differently, and each of those columns is where the looks, you know, like the variant looks are, and that's all hidden, or that's all tucked under this base layer. And then we basically, when you add another layer, you're setting up the columns themselves to have the different variants. So there's no look layer because it's picking up the look from this base. Now if I were to hide this, you're going to see that because the wall top is hidden in here, you're not going to see that in the other design layer. So you need to have that set or turned on. So this is kind of like the foundation for the design. Structure, design foundation, and the design proposals. Hopefully that makes sense. That kind of gives you an idea of how the LIVERPS rules work. And next we're going to talk about structural integrity, because one of the interesting things is, as a designer, if I'm like, hey, you know, I really want to move this column because it's just blocking my view, I can do that. It doesn't seem right. As a designer, I might walk away thinking, yeah, get that thing out of the way so we can see the beautiful view out the window. And as an engineer, you're like, sorry, bro, you can't do that. How do we prevent that? How do we prevent the designer from submitting that as a proposal? Well, that's where we're going to create an extension. LIVERPS prevents them from doing it through the layer ordering, but we're going to create an extension to inform the user you're stepping out of your boundaries and you need to not do that. So that's how we're going to create this extension. Move that back. Now, just because I don't want that here, I'm going to go ahead and clear this. Delete that delta. There we go. Okay, when you're architecting content development pipelines, your goal is to think about every single user. You're going to think about the engineer's perspective. You're going to think about the designer's perspective. You're going to think about the teams who are maintaining the pipeline, the actual developers of the pipeline. So you need to think how you need to try on as many hats as you can and be empathetic with all of your users and try and make their lives as easy as possible. So we've already done that from the design reviewer perspective. They don't have to go through and change every single column. They can simply just change the layer, hide the layers to show and hide the design proposals. You know that the engineering structure is safe because of just the way USD works, but you're also ensuring that it's the piece that is really important. What we're going to do here is that the designers can make a proposal that is not allowed, and then that costs money and time, and to save that effort we're going to create a simple extension. I've already made that. I'm not going to go into the details of what, how to make an extension in this video, but I want to show you how that works here. So if you open up the extensions panel by clicking the developer window, it takes a second to load. Sometimes it's a little slow. And we can come over here and you can see my structural extension. Well, we don't want to open a VS Code. Basically, we can enable that. And really what I've done is I've set it up under, I've just created a simple extension that lets people know when they shouldn't mess with a structural prim. And if we turn that on, you'll see that, let's hide that. It gave us a little toast saying that the structural prim extension is active. If I come over here, let's pick this one because this is the one that's kind of in the view. If I go and move this now, I get an alert saying structural element moved, yada yada, what element, check the LIVERPS authority before editing. So it warns them. So they at least see this and know, uh-oh, I probably shouldn't have done that. I'm going to put it back. And technically what you need to do is delete that delta. I mean, it's just, I like clean data, so your users may not delete that. But that's all it takes, is just putting some kind of a message in front of them, because USD doesn't block you from moving it. This message just warns them you're doing something that's out of bounds, and that reduces the risk of the designers doing something they're not allowed to do. And that's huge for corporations who are looking to save, doing massive content development pipelines where there's a lot of work going on, a lot of people involved. Time is money. So let's take a quick look at that extension. The first thing is, one of the things that we've done is when we spun this up, we're using the Omniverse USD, the MyUSD Composer Kit. That was what we built. That's the application that we're running, and that is got the MyUSD Composer setup extension, and that you can see here, and that was already built in. So what I did is I cloned that and just kind of made my own version where I called it structural check extension. And the bare bones components for this are that you set up your prefix and your suffix, like a mycompany.structural check extension. You need a config file with a toml, and that toml is here. Sorry, I'm going to back up. That application that we're running has this extension as a dependency. That is really important to call out, because it's sort of like if you're building an application and you want to include this extension in it for your pipeline, so you make sure that your teams are using it. And you can auto-enable it by including it in this dependency list. So looking at my custom extension, it's pretty simple. It's just giving you the bare bones package information, like the title on the version and the description. And then we have our dependencies where we got OmniUSD and Kit Notification Manager. And then we have the my company structural extension, where to look for the module. And then underneath this, you can see that is the configuration so that Omniverse knows where to find it. And then your actual script this is a Python script that lives under my company structural extension. You can see that the folder structure needs to match the name here at the top. And you have a Python init, which we'll call your structural guard extension, and your extension script. And I won't go into too much detail other than on startup is a key thing, and then you sort of set a timer so that you don't just throw toasts up in their face all the time, and then you let them know that the guard is active. And then you've got the on objects change, and that's basically where you get the info for the path, and you find any, you get that path here, and then you find any attribute that has our tag. That's the critical piece here, and this is where you can adjust your script to find anything you need, whether, I don't know, I mean literally sky's the limit here. And then once you have moved that, it warns you structural movement detected. This is printing to the log, which you can see here. Actually the logs are down here with my previous moves, and then it warns the user, notifies them whatever information you want. And then you can throw an error if something goes wrong, and you shut it down. And this just closes the API connection so that if you turn off the extension, that it wraps everything up clean. And that's pretty much it. I mean, that's as far as I'm going to go into that. But you can see how such a simple extension is worth the effort. It doesn't take long to create something like that, especially if you use AI to write your code quickly, which everybody's doing these days. And I mean, writing code with AI really has streamlined development immensely. I won't even get into some of the tools that I use for work. They're really impressive. I love them. But you can see what a huge difference this makes for your user and your organization who you're building this pipeline for by reducing the cost. And that's the goal as a pipeline architect. So as promised, I wanted to dig into why I love USD. And to do that, we're going to look at the OpenUSD.org website, where obviously this is a Pixar specific heading here. I love this little birdie and a crab. I mean, if you know me at all, you know I love cute things. But I wanted to show you what's going on under the hood, like how this data works. You can see that in here, it's a file structure. The layers themselves correspond to the files that we create, and in there we still have that source engineering file, which is our base. You know, this is where the LIVERPS comes in to maintain structural integrity, because your non-destructive changes mean that your lobby stays exactly how it was, even though you've altered it considerably. But what's it look like under the hood? I mean, you've got files. Is it data? What is it? Well, it's actually both. So if you go to the frequently asked questions here, you can say, what does USD file look like? And it gives you an example. Let's zoom in a little bit so you can see that better. There we go. So they use a planet as an example. You have a class of planet, and you have a solar system, and let's say we define Earth. Well, it references the planet USD file, and it has life, true. It's blue, a color of blue. And then you can create another one called Mars. So your solar system contains multiple planets that reference the original planet. And it just keeps going from there. You can do all kinds of really cool things where you can add all the different properties and everything, but you never modify the original planet. It's basically object-oriented programming within a data structure that is just very intuitive once you get into it. So if we look at our original lobby design USDA, which I saved as a USD so you can see the human readable version, you can see it's got lots of information, but it's still very straightforward and easily structured, where you can see the sublayers, and there's some syntax specific details, but like it's not that hard to really understand when you come in here and read it. It's just each object has very specific properties and naming conventions, and it's layered appropriately. There's different data types like X-forms, and whether or not it's rendering, you know, all the details here. So textures for Hydra, which is your renderer. Again, outside of the scope of this, but so it does get more and more complex as your file gets more robust, but it's not that hard to understand what's going on here. The other thing that I recommend is that you check out the Book of USD. This has all kinds of, like, literally anything and everything you want to learn about USD. It talks about the composition arcs, where you've got the local layers of reference, the variable sets, but then also the strength ordering. So this is where you can learn everything there is to learn between these two websites. I think you're going to get lots of information, but then don't forget, NVIDIA has tons of stuff to help you learn USD, and there's lesson plans and everything. And again, check out their community for Omniverse, where you can contribute. All right, I think that pretty much covers it. Now, we've bridged the gap between engineering intent and interactive design without breaking USD principles, and that enables scalable, constraint-aware digital twin workflows. So that's pretty awesome if you think about it, and it really wasn't that bad. I hope at least you feel that way after seeing this. Be sure to check out the blog article for this project on tech-multiverse.com, where I've written up the same process that we just showed. Be sure to check back if you're interested in seeing more USD projects. Thanks for watching.